So with this one, we're going to be looking at finding zeros and vertical intercepts, which are two things we've done already with other functions and specifically with polynomials, and the process will be very, very similar to that. And then I'm also some more practice with those horizontal asymptotes and vertical asymptotes. So we're really focusing on the zeros and vertical intercepts because then once we have those, we have some points to graph. And then with the asymptotes, we get some idea of short run and long run behavior. And then from there, we can start putting a graph together with these kind of important features. So let's start with finding the zeros of the graph. So the zeros of the graph, that's the same thing as saying x-intercept or horizontal intercept. Those are going to occur where the numerator, so taking that numerator function p of x, and seeing where does that equal 0. The vertical intercept is when we plug in 0. So if we're calling all of these f of x, then finding the vertical intercept is evaluating f of 0. And then horizontal asymptote and vertical asymptote we talked about before. So horizontal asymptote will have to compare the degree of the numerator and the degree of the denominator and see how they compare to each other. We'll have those three cases. Then the vertical asymptote is going to come from where we take our denominator function, q of x, and see where is that equaling 0, since that will be where our function's undefined. So let's go through this for each of our cases. So our first function is x plus 1 over x squared minus 1. So if I want the zeros of this, so zeros, we're taking that numerator, x plus 1, and seeing where does that equal 0. And we'll have subtracting 1 from both sides, x equals negative 1. So this is giving me the coordinate negative 1, 0. The vertical intercept, or the y-intercept as it's also known, is where we plug in 0. So we're looking at f of 0, which is, let's see, 0 plus 1 over 0 squared minus 1. So we're having a 1 over negative 1, which is negative 1. So we have a vertical intercept where x is 0, y is negative 1. Let's see, if we want the horizontal asymptote, the degree of the numerator, so from x plus 1, that degree is 1. Denominator, x squared minus 1, has a degree of 2. So this is a case where the degree in the numerator is smaller than the degree in the denominator. So that means we have a horizontal asymptote at y equals 0. And then for our vertical asymptote, we're going to take the denominator, that x squared minus 1, and see where does that equal 0. So I'm going to add 1 to both sides, take the square root, and we're going to get x equals plus or minus 1. So we're going to have two vertical asymptotes, x equals negative 1 and x equals positive 1. Something we'll notice here is how this negative 1 is coming, x equals negative 1, is coming up as a vertical asymptote and a 0, and that's an issue, because what that means is that when I go and try to plot that 0 at negative 1, 0, it's actually undefined there. We can't plug in x equals negative 1. So what I'm going to do is I'm just going to highlight that. And I'll talk about that when we get to actually graphing it. So we'll come back to that idea. But basically, I'm going to give it away anyway. When the 0 is the same as a vertical asymptote, that's going to create a hole in the graph. So we'll come back to that, but I just wanted to mention that here where we're solving, basically we found the zeros, even though that 0 technically is a hole in the graph, because we got something that's actually undefined. Okay, let's go to our next function here. So we have x minus 1 quantity squared over 3x squared minus 1. So with this one, and if it's helpful, you could FOIL out that numerator, so x minus 1 times x minus 1, so that's x squared minus 2x plus 1 over 3x squared minus 1. Let's go ahead and take a look at that. Having it in that format will be a little bit easier here, especially when we get to the horizontal asymptote. But let's start with the zeros of the graph, which actually for the zeros, the factored form is more helpful to us, because what we're doing is we're taking that numerator and setting it equal to 0, and if we want to solve that and it's quadratic, we'll want to be factoring. So we have x minus 1 quantity squared equals 0. I'm going to take the square root of both sides, so that'll be 0 equals x minus 1, add 1 to both sides, so 1 is equal to x. So I'm getting a 0 of 1, 0 as a coordinate. All right, the vertical intercept, we're going to plug in 0. So we're looking at f of 0, which is 0 minus 1 quantity squared over 3 times 0 squared minus 1. Let's see, negative 1 squared is positive 1. 0 minus 1 is a negative 1, so we're getting negative 1 out here. So we're getting a vertical intercept at 0, negative 1. All right, the horizontal asymptote. So the degree of the numerator is 2 from that x squared. The degree of the denominator is also 2 coming from that 3x squared. So when the degrees are the same, our horizontal asymptote is going to be a ratio of the leading coefficients. So our leading term is 1x squared in the numerator, and in the denominator our leading term is 3x squared. So I'm going to take that 1 from the numerator, 3 from the denominator. So we're getting a horizontal asymptote at y equals positive 1/3. Then for the vertical asymptote, we're looking at taking the denominator, so 3x squared minus 1, and seeing where does that equal 0. Add 1 to both sides. Divide by 3. Take the square root, and x is going to be plus or minus square root of 1/3, so 1 over root 3. So we're going to have two vertical asymptotes. Notice this time that the vertical asymptote doesn't line up with a 0, so that means these are going to come through as clearly vertical lines that we can't cross. So we'll take a look at that graph when we get there. All right, last one here, 1 over x plus 2 quantity squared. So for the zeros, we're going to take that numerator, which is just 1, and set it equal to 0 and solve, but there's nothing to solve for. We just end up with a statement, 1 equals 0, which is a false statement. So what that tells me is that there's no zeros. We are not crossing the x-axis there. We're not crossing. All right, then we go on to the vertical intercepts. Intercept, there's only one of them. So looking at f of 0, we're looking at 1 over 0 plus 2 squared, which is going to be a 1/4. So we have a coordinate 0, 1/4. Then horizontal asymptote. So the numerator is just 1, so that tells me the degree of the numerator is 0. In the denominator, we have this x plus 2 squared, which if I FOIL that out, it would be an x squared for the leading term. So our degree in the denominator is 2. So when we compare, the degree of the numerator is smaller than the degree of the denominator, which tells me the horizontal asymptote is y equals 0. Then for the vertical asymptote, we're going to take that x plus 2 quantity squared and set it equal to 0 and solve. So I'm going to take the square root of both sides, so x plus 2 equals 0. Subtract 2, so x equals negative 2. So at negative 2, we're going to have vertical asymptote. Okay, So that's how we find these kind of key features. And then what we're going to do in the next video is start to put together a sketch with this information, kind of see how it comes together for our rational functions.